Hi everyone. Welcome to the new Trading and Risk Management with Python video series. In this first video, we'll explore how to create a simple value at risk calculator using Dash in Python. This initiative, brought to you by Mhamed Bettaieb, is designed to help professionals better understand the industry and leverage the power of Python for solving issues and improving analysis efficiently as part of Bond Consulting Skills Sharing Program. Creating a simple value at risk calculator involves a few steps, and I'll guide you through the process, providing a basic outline of the code. Our application will include the following components. Profit and loss vector generation. We'll start by generating a year's worth of profit and loss data. For this example, we'll simulate this data. Dash layout. Next, we'll set up the Dash app layout, including a graph to display the profit and loss distribution and a slider for selecting the VaR percentile. VaR calculation and graph update. We'll then calculate the VaR based on the selected percentile and update the graph accordingly. Before we begin, make sure you have Dash and its dependencies installed. You can install them using pip as per the code on the screen. Let's dive into coding the app. This code sets up a Dash web application. It generates a profit and loss vector for 252 business days, assuming a normal distribution. You can adjust the mean and standard deviation as per your data or model. Our app includes a histogram to show the profit and loss distribution and a vertical line to indicate the VaR at the selected percentile. The slider lets users choose the VaR percentile, and the graph updates accordingly. To see the application in action, run this script in Python. It will start a local web server, usually at http://127.0.0.1/8050. Open this URL in a web browser to interact with the app. Remember, this is a basic example. In a real-world scenario, you would use actual profit and loss data and might need to consider other factors depending on your application's specifics. Now, let's go through the code, step by step. Step 1. Import necessary libraries. We'll use the Dash framework for creating web applications, DCC for interactive components, HTML for HTML components, Plotly for creating interactive graphs, and MP for numerical operations. Step 2. Simulate 1-year profit and loss data. We'll set a random seed for reproducibility and generate simulated daily profit and loss data using a normal distribution. Step 3. Initialize the Dash app, creating a new Dash application. Step 4. Define the layout of the Dash app. We'll create a div to hold the components, including a graph component to display profit and loss distribution and a slider component for selecting the VaR percentile. Step 5. Define a callback for dynamic interaction. This will update the graph and VaR text based on input from the slider. Step 6. Define the function to update the graph and VaR value. We'll sort the profit and loss data, calculate the VaR index, get the VaR value, and create the figure with a histogram. We'll also add a vertical line for VaR and update the graph layout. Step 7. Finally, we'll start the Dash server to run the app in debug mode on the local server. And that wraps up our walkthrough on building a simple but powerful value at risk calculator using Dash and Python. As you can see on the screen, the final code and the app interface are designed to be both user-friendly and highly functional. Notice the interactivity of the web page that Dash enables. The graph is dynamic and responsive, providing a clear visual representation of the profit and loss data distribution. What's particularly intriguing is how interactive elements, like the VaR percentile slider, integrate seamlessly into the application. As you adjust the slider from 90% to 99%, observe the immediate impact on the graph. The vertical line, representing the value at risk, shifts accordingly, reflecting the percentile change. This immediate visual feedback is crucial for professionals in risk management and trading, as it allows for quick and intuitive analysis of risk exposure. This application is more than just a tool. It's a demonstration of how Python, combined with Dash, can be employed to solve real-world problems in capital markets. It exemplifies the power of Python in financial analytics, turning complex data into actionable insights through interactive visualizations. This is just the beginning of our Python video series focused on capital markets. We plan to release more content that delves deeper into how Python can be leveraged to address various challenges and opportunities in the field. We hope this video has been informative and inspiring. If you enjoyed it and are looking forward to more content like this, please support us. Don't forget to subscribe to our YouTube channel, leave a like, and share your thoughts in the comments section. Your feedback and engagement are what drive us to create more content like this. Thank you for watching, and stay tuned for more insightful videos on capital markets and Python.